So, it is time to begin. Our today's speaker is Maxim Pavlov, and he will speak about Dubrovin's paradigm and beyond. Yes, is that correct? Translation, Max. Сейчас мы ее только распутаем.
Я должен это в карман.
Это в карман, а это куда-нибудь, чтобы вот эта штучка торчала где-то недалеко от... Можете прицепить сюда.
Непонятно, как она крепится.
Вы можете просто вот этим зацепить, а можете на голову надеть. Можно вот так, а можно вот так. Как вам удобнее.
Нет. Так, интересно, меня слышно или нет?
Я думаю, что...
Непонятно. Ну ладно, поехали. Значит...
Вы будете по-русски?
Okay, I will speak English. Yes. So I will speak about one interesting object, in my opinion. So I'm speaking about system of equations for coefficients beta ik, which depend on R1, R2, Rn, so many coordinates and natural numbers. System of equations finally takes the form I not equal j not equal k. So every triple of indices is distinct.
Summation?
No summation.
No summation.
All three indices are distinct, pairwise distinct three indices. Okay, so this is a system. People call it Darboux system.
Oh, Darboux system.
Darboux system. Okay, so this is nonlinear system of equations. This di means derivative. Di, d, dri. So we have n coordinates, r1, r2, up to rn. We have derivatives with respect to these coordinates. So we have this nonlinear system of equations. This is the object Darboux system, which is under my consideration. This is target of my talk. So the question is it possible to integrate this system of equations for n equal? Yes, of course. N equal 3, 4, 5, etc. So this system is interesting for this number of coordinates. This system is integrable. Why this system is integrable? Because the system has so-called lax representation. So I can write following linear system of equations: hk, beta ik, hi, where hi again depend on r1, r2, rn. So if I
take this function,
hi satisfy linear system of equations. If I check cross derivatives, dj hk, dj di hk, for every three distinct pairwise indices, I come here. So this is linear system of equations. Linear system, or we can call it lax representation.
n squared.
Huh?
N squared.
Beta ik not determined for coincident coefficients. So n square minus n. Yeah. Okay, so this is the.
So this is not determined for n equal 1.
For I not equal k, and this system. Yeah. Yeah. And so this. Yeah, this is a linear system that I told you, like we can interpret Lax representation. Verification of this condition lead us to Darboux system. But.
This inequality doesn't mean that I is
For every triple pairwise coincided indices. So coincidence is forbidden for all triple of indices. I cannot be equal k. If you like, I can write. So let us introduce psi I. R1, R2, Rn. We had one linear system of equations for unknown functions hi. We would like to introduce alternative set of functions psi I, so we can call it vector function h, this vector function psi I, and I will write, be careful, di psi k, beta ki psi k. Yeah? It's what's correct. So I, but here one matrix beta, and this is transposed. Dual. So obviously, this is not necessary to prove.
I asked you to explain why it's interesting. Of course, you've told me more than once.
Yeah, I am going again. So if you check again, dj, di psi k, di, dj psi k, for every triple of pairwise distinct indices, you come back again to the same Darboux system. This is obvious. I just one matrix changed to transposed. So this system, Darboux system, possesses two alternative Lax representations. This is one Lax representation. This is a joint Lax representation. A joint. So we have two boxes, 1 and 2. And of course, if we know any solution of this system for given coefficients beta ik, so we assume that we know some particular solution of this nonlinear system. Let's take corresponding linear system of equations. Assume that we are able for this given solution, for these coefficients beta ik, to find solution of this linear system. Assume. The question, is it possible to compute solution of this adjoint linear system? Of course not.
I mean, if you know all the h's, can you find the psi?
Yeah, we cannot. In general case, we have no chance in general. Hmm? Yeah. So the question is what to do. If I know solution for hk, I would like to construct solution for psi k. What to do? And idea which was suggested by Bogdanov and Ferapontov, I call it Bogdanov-Ferapontov approach. Was following. Let us assume, so I am not speaking about general construction. Nobody knows what is general construction. I am speaking about very interesting particular set of solutions. We assume that between one class of solutions and second class of solutions, we can construct a bridge which we can call linear differential operator of some given order. For instance, we can say, let us looking for hi is ai psi I, where ai are some unknown function. I need just to substitute this expression here, check compatibility with this equation, because this equation for psi, after this substitution, this equation also for psi. So this verification leads us immediately to restriction on coefficient ai. this could be nothing but constant. So simplest case. AI is a constant.
Why is it constant?
I take this expression, substitute here and here. This is linear system of equations for psi. And this is linear system for psi. This is overdetermined system. More equations than necessary, twice more. So once I remove all dependencies, I am speaking about derivatives, I come to conclusion that AI could be just constants.
It must have restrictions on beta also.
Of course, of course, of course, of course. This second step. So since AI are constants, we have just two distinguished cases. Or AI are zero, we just ignore this trivial case. Or AI, we can rescale up to unity every time. So I will consider AI is just unity, one only. In that case, if I say, let's fix AI as one, this means that beta ik are beta ki. This is so-called Yegorov case. Yegorov case. 100 years ago, people write Yegorov. Doesn't matter. So this is Yegorov case. Symmetric.
Sorry, I read in your abstract, but it should be what Frobenius.
Yeah.
Mistake.
Yeah, of course. I'm coming. So this is first class of restrictions, but this is just simplest case. Let us, so this is so-called zero order transformation. I'm looking for differential operator of zero order between one linear system and another one. Second idea is following. Let us looking for HI is some AI psi I, comma means derivative. Derivative similar.
If you assume, for example, that HI is not just proportional to psi, but is some linear combination.
Yeah, okay. Okay, we take these rules. Yeah.
Yes, and then what will be the result?
All other constants are zeros.
So the diagonal case is only one.
Yeah.
What happens? You take it generally.
Yeah, then you will see that all other constants must be zero. Yeah. But it's easy. Question was, if I take HI is AIM psi M. It was a question. Yeah, with summation, including all indices.
Without zero order term.
No, this is not the end. Plus and the rest, lower and lower terms. So if I write here, for instance, psi I k, any k, I know due to this rule, I can express all derivatives. Yeah. Yeah. So I need to keep just leading term. So finally, I just give you answer.
No, I meant zero order. What does dot mean?
Dot means zeroth order that you saw here. Plus A, K, M, psi, M. Yeah? That you asked me before. Okay, so what is the result of computation? Absolutely the same. It takes 15 minutes maximum. You take this expression, again, substitute here, here. You compare with this system of equations. You have overdetermined system. You check verification of all elements and come finally to observation that hi is psi I plus some m not equal I beta mi psi m. This is answer. This is ansatz. This is answer. Ansatz. This is answer. Sorry for my broken English.
Not broken at all.
Ansatz. Yeah, so here could be a coefficient again, like here. But absolutely the same logic. It could be only constant, and by appropriate scaling, every constant could be excluded. So finally, we have this right hand side.
No condition.
No.
On beta.
Okay. No, the same betas, but different condition. Di beta ik, dk beta ki plus sum m not equal I not equal k. Beta mi beta mk equals 0. This is a condition. Precisely. So now I'm going to explain origin of all elements here.
In general, what break dependent, not differential break dependent between AI and psi I, then there's no nothing.
What means general?
I mean, psi I are some assume like for further about matrix. Psi I are a solution for matrix linear transformation to the effect of each.
So I'm speaking about Bogdanov-Ferapontov approach. Yeah?
I mean, if it does work, that's
So let's consider system of equations. RIT, HI bar, twiddle, HI bar, RIX. Let's consider such a system of equations. So these functions you already know depend on R. These functions depend on R. So I take two particular solutions of this linear system of equations. Assume that I know some solution of this system, Darboux system. Let's take some particular.
Differ by some initial boundary.
No, I'm not speaking about boundary. I am going to explain.
You mean that H tilde and H bar are some particular solution?
Some particular solution.
Or the same things?
Just let me pronounce. Please wait a few seconds. I take any particular solution of this Darboux system, any particular. Take this corresponding linear system of equations. I would like to solve this linear system. Let's take two particular solutions of this linear system of equations. One of them I call HI bar, second one HI twiddle.
So the difference between them is they solve different boundary conditions.
Why you use concept of boundary conditions? I don't know. I just take two particular solutions. Any two particular solutions. You see, this linear system of equations for given coefficients, beta ik, has general solution parameterized by n arbitrary functions, n, of a single variable. So I take two just particular solutions. Idea is following now. Please concentrate on my words. Here are I, were independent variables. Now in this construction, they are functions. They are no longer independent variables. Here they are functions which depend on x. So HI bar depend on R, all the same set of x and t. HI twiddle. Again, function of R of x and t. So here derivative with respect to x, here derivative with respect to t. This is so-called semi-Hamiltonian hydrodynamic type system integral by Tsarev generalized Vodograph method.
H tilde and H bar do not depend on derivatives of R, they only depend on R.
Depend on only on R, particular solution of this linear system. Yeah. So what I would like to emphasize now, we had some non-linear system of equations. We had two linear systems, which we can call Lax representation and joint Lax representation. They determine Darboux system. So this system is integral because this system has Lax representations. Usually we know that if system has Lax representation, we can use this knowledge to construct corresponding solutions of given nonlinear system of equations. But now I am talking about second technology. I take this linear system of equations, I take two particular solutions, I construct this hydrodynamic type system, and my idea is I would like to integrate
Something like Hodograph.
transformation is hidden. I'm not talking about Hodograph transformation. I just like to say that Hodograph transformation is applicable to integrability of this system of equations. I just would like to say, again, this is separate story. One story is this object. This is second story. Another non-linear system of equations, or better to say quasi-linear, but doesn't matter, this is not linear. This one system, this another one. For both systems, we use Lax representation. We have non-linear system, we take one particular solution, we take corresponding linear system, we take two particular solutions, which we call HI bar and twiddle, construct corresponding system of equations. This system also is integrable. This set of bridges. Okay, so if I write this system of equations in a form RIT, Vi of R, Rix, this object come from many different applications, no summation here, of course. So the question is, what possible to say about Hamiltonian structure of this system? This question was formulated first by Dubrovin and Novikov. And they introduced a concept of Poisson brackets, which people after them call Dubrovin-Novikov Poisson brackets. I am not going to go in detail in this object. I just would like to say and attract your attention that exactly with the concept of Hamiltonian structure for this hydrodynamic type system was introduced J, K, L, Riemann tensor of curvature. And if I take all pairwise distinct indices, I not equal J, not equal K, not equal L, etc., all pairwise distinct indices, this is 0. For I not equal J, not equal K, not equal L. However, if I take R, J, K, I, you see two coincident indices. This is 0 for I not equal J, not equal K. Give us Darboux system. So again, this is, please consider like sketch. Some steps I avoid from my description. I just constructing bridges for you. I'm constructing this condition, Riemann curvature condition. Give us on language for 3 distinct indices Darboux system. In fact, this is observation made by Darboux, not me, by Darboux, Gaston Darboux. And the last step, if
you mean that you started from a Darboux system, you constructed next pair, yes? Then you constructed this evolution of this system. And using this Riemann tensor, you return back to,
Yes,
to the same.
yes, precisely. And last step is this one, Rk, Ik equals 0. So this is for all distinct indices identically correct. To Ik. So one of indices I raised up
With the help
of metric of corresponding. I told you that here is a metric is inside here. So this condition lead us precisely here. This is the same. Again, this observation made by Gaston Darboux.
And why was he interested in such a system? From
Darboux?
Yes, from geometric.
Of course, because you see, you can take a metric d square, consider, let's say, dxi square, Cartesian coordinates. Then you say, I am looking for special diagonal coordinates, GKK, DRK square. So it was an idea at the time when people looked for so-called orthogonal curvilinear coordinate net, something like that. It was one of many interesting objects. And if you go to these coordinates, you come in this picture. Yeah, precisely. Because in this language, GKK is nothing but HK bar square. Bar square. This is important. JKK. So, what I told you at this moment, I told you existence of zero order transformation between a joint linear problem and given linear problem, which lead us to Yegorov restriction. Second point, if I am looking for differential operator first order, I come to the so-called zero curvature representation, which means that our metric is flat. And Bogdanov and Ferapontov, they were interested to consider more and more complicated constructions. Since I'm a little bit restricted on space, something I need to remove. Да, это я помню. Но при этом придется что-то закрывать. So, for instance, I can say, I am looking for hi, again, some unknown function, psi I. So I'm looking for now second order operator. It was first order, now I'm looking for second order. Again, this is how to look, Oleg, why this is not so complicated. You say, I have one linear system of equations, I have second linear system of equations. I'm looking for matrix differential operator of nth order matrix. If you just substitute corresponding matrix differential operator of any degree of order, second order, definitely you will come to similar results which we obtained by Bogdanov Ferapontov. This is just straightforward computation. No any hidden tricks, just straightforward computation. And I just would like to, before I continue, to say that and zero order relationship between two linear problems and first order relationship between two linear systems give us two objects which we call Riemann geometry. But Ferapontov and Bogdanov proved that this object of projective geometry if order higher than 1. So this subject of projective geometry, I am no longer going to tell about geometry. So this paper, Bogdanov Ferapontov, is easily available in electronic archive. It was published. You can find this paper, read. Any details are in this paper. I just would like to say that they repeated computation not only for two indices. I mean, for instance, a
But the base, the part that you have iteration equation beta, your base is beta. Your base is J, because your base is, what is your base? What is your base?
I have this nonlinear system of equations, and the question, what could happen with this nonlinear system if I add any kind of restrictions like this? Statement is that I have this nonlinear system. If I am looking for instance, first order differential operator, this is extra set of equations, extra. Huh?
Consequent.
Yeah, yeah. So, for instance, if I take n equals 3, here you can compute, this is 6 equations for 3 distinct indices. Here, 6 equations, n equals 3. If you take these extra equations, 1, 1, 2, 1, 1, 3, 1, 2, 2, 3. You have here 3 equations, 3 and 6, 9. So under this restriction, instead of 6 equations, you have 9 equations. So your system, Darboux system, grows correspondingly, and class of solutions reduces. So again, instead of second order, I can write psi I, etc. Second order, third order. Of course, I can continue and continue. So Ferapontov, Bogdanov, they made computation only for second, for third order due to expanding of formulas like blow up, huge amount of formulas, and better just for illustrative purposes, restrict consideration on second and third order that they did. Okay.
The result of Bogdanov Ferapontov is that it is projected just.
Yes, precisely, precisely. Yeah. So what could be in such a case? Let me just write answer. HI is CI. They, instead of A, they use here C. C. C are constants. So again, I said you, or they are zeros, or they could be yeah, normalized to unity. So I just will follow them. Psi I minus UI psi I will explain. Plus some m not equal I Tm beta Im dm beta mi. No. Psi m minus dm beta Im psi m. Here derivative. This is just multiplication. So
BIMM, BIM comma M minus IM.
yeah. So this is first order part, this is second order. And of course, I need to explain what is it U. What is it U? So for U, I write here formula. dj UI is beta even 3 beta ij dj beta ji minus plus beta ji di beta ij. My mistake is here. Bij di beta ji. Yeah. So this definition for UI. So if I know solution of this nonlinear system of equations for this second order transformation between two linear systems of equations, then UI can be reconstructed according to these given expressions for beta ij. So this way, how to find u. But this is not the end, because I promised you, yeah, should be a restriction for beta. Ci to, to I beta ji minus ui beta ji minus cj dj beta ij minus uj beta ij, and the last term m not equal I not equal j cm beta m dm beta mi jm minus beta jm dm beta im equals 0. So we have this nonlinear system of equations. We have two corresponding Lax representations. Now we say we are looking for differential transformation between set of solutions psi and set of solutions ihk due to this second order formula. Then we come to restrictions that ui can be reconstructed in terms of b if beta satisfy some extra set of equations to this originally given system. So what I told you that we have infinitely many approaches how to consider particular cases of solutions for this nonlinear system of equations. So you see, on language of integrable systems, we have this integrable system. And the question, how to integrate this system? Technology is following. Let us looking for transformation of that type, first order, second order, etc., between one Lax representation and a joint Lax representation. Why? Because this approach leads us to restriction of class of particular solutions of corresponding integrable system. This is idea.
What is the meaning of the condition?
That I told you, this is written in paper written by Bogdan and Ferapontov. They explain these expressions from logic, from theory of projective geometry. Yeah.
Projective connection.
This precisely written for operators of second and third orders. But of course, and for all others, they gave more general picture in more abstract language.
They also computed for the case of third order.
They computed. Bogdan and Ferapontov, yeah. But larger expressions. I'm coming. Сколько еще времени у меня? Времени сколько стоит?
8 сейчас, у вас полно времени.
Ну, хорошо. Ну что, я продолжу?
Да.
Окей. So what is Dubrovin paradigm? This paradigm, what? Maybe in such case, the Dubrovin paradigm. Okay, I follow Ian. Okay, so, хорошо. Хорошо. So, Dubrovin paradigm contains two steps. First is we would like to find all particular solutions of this system of equations. For all I not equal j not equal k. Darboux system. So question is, we would like to construct all particular solutions. This is hidden inside of his plenty of papers. If we know this solution, we would. No. This correct question, but you are too fast. Let's take this system of equations, beta k, I not equal k. So we would like to construct solution of corresponding linear system of equations for Lax representation for this system. Then we would like to compute corresponding two particular solutions that I told you from the beginning and construct corresponding hydrodynamic type systems or semi-Hamiltonian integrable systems. So HI bar and HI twiddle, just two particular solutions of this linear system of equations. Then second, we would like to take this system of equations, Rix, and find epsilon square some block, epsilon 4 some blocks, etc. We would like to construct infinitely and infinitely higher order terms. This is differential polynomial with respect to R up to, for instance, third order derivative. This is fifth order derivative, etc., etc. Or if you wish, up to second order, third order, etc. It depends on corresponding type of system of corresponding restrictions. Anyway, so I'm talking about so-called dispersionless limit. Dispersionless limit. So this limit. If I speaking about integrable systems, not about all integrable systems, but about plenty examples of integrable systems known for last 60 years. They have dispersionless limit, so we can remove all higher corrections, dispersive corrections, and go back to dispersionless limit. So idea paradigm, Dubrovin paradigm was following. We would like to reconstruct integrable systems, dispersive integrable systems, starting from corresponding dispersionless limit. We have some system of equations for given HI bar, for given HI twiddle, and taking this dispersionless limit, we would like to add in a right way higher and higher dispersive corrections such that our this extended system will have corresponding Lax representation.
Why positive? Even powers.
No, I told you that this I write for simplicity. Let's, okay, to avoid any misunderstanding, right here, these orders. It doesn't matter. I just would like to say that it was idea to find a regular way how to add higher order differential polynomials as corrections. It was his idea. And the statement is that still this program is at the beginning due to huge complexity of corresponding computations. So contemporary computers do not allow to do computations for a number of equations higher than 2. And even in two-component case, this is a big problem. Yeah. So.
What about one component case? Just one component. Would you be standard?
Yeah. Yeah, Dubrovin exactly wrote some papers, and his students and his colleagues later, they wrote plenty papers devoted to one component case. Even one component case is interesting. But for me, case interesting starting from 3, not from 2. Because I prefer 3 distinct indices. Yeah. Okay.
So we expand the special system to system with dispersion in such a way that the result is box result.
Yeah. And of course, this is very wide program, wide. So Dubrovin cannot do so very wide program because in opposite case, he will work 24 hours every day. Oh, of course, yeah, precisely. Of course, they have some, better to say, at the best of my knowledge, some ideas how to prove that this infinite series is really exist. So you indeed can look for new terms, and you should not expect that once you come to some obstacle and it means that solution does not exist. So this is a separate story. But anyway, this is again big program, and Dubrovin considered narrow class of solutions. What means narrow class? What means narrow class? Narrow class means following. 3. He said, let us do not consider general picture. Let us consider narrow picture. Narrow picture, you remember, beta ik is beta ki. Yeah? Yegorov. This is the first one. I not equal k. Second, he said, okay, let us consider di beta ik plus dk beta ki plus sum m not equal I not equal k beta mi beta mk equal 0 for I not equal k again. Yeah, this one. So this is second. Yes, because Dubrovin started on 10 or maybe 15 years earlier. Yeah.
No reason to expect it's related to this class. It turns out that this program.
In some sense, yes, but since I'm speaking about Riemannian geometry, I'm speaking about tensor of I removed of curvature. So on that language, it was explanations that this simplest case simplest, because this means this condition that we deal with local Hamiltonian structures of Dubrovin-Novikov type. So if we are speaking about this hydrodynamic type system, we say that its rotation coefficients, I maybe forgot to say beta ik, people call rotation coefficients. So beta ik are symmetric rotation coefficients, symmetric. But if this system has local Hamiltonian structure, this means that this condition is fulfilled. So again, be careful what I'm talking about. This is 2 absolutely different conditions. One condition come from existence of 0 order relationship between one linear problem and another one. Second condition come from existence of first order differential operator, 2 different stories. 0 order operator, first order operator. 2 different stories. So what I'm talking about? I'm speaking about existence of class of solutions for Darboux system such that one condition which came from 0 order restriction, second condition which came from first order restriction, nevertheless, they have common subset of solutions. Common subset of solutions. So they are not in contradiction. They have common subset of solutions. in language of hydrodynamic type system, this is okay. This is from psychological point of view easy to accept. You consider this hydrodynamic type system, say, okay, let rotation coefficients will be symmetric and satisfy the system. Why not? But let me just show what happened if you consider just restriction 2, this one, restriction 2. You have this lengthy equation, maybe nobody from you can remember. This easy. Let me beta ik substitute here and here. Let me just substitute. You see, di beta ik plus dk beta ik plus sum m not equal I and k beta mi beta k m. Maybe better bit. Let me write in right way. Beta im beta mk equals 0. So what is it? Due to this formula, dm beta ik, beta ik, beta ik, beta ik. So finally, this formula I can write in the form delta beta ik equals 0, where delta is nothing but so-called shift operator. Shift operator. So this length equation under symmetric condition immediately takes the compact form. What means shift operator? This means that all rotation coefficients now depend not on R1, R2, up to Rn, but they depend beta ik on R1 minus R2, R1 minus R3, etc. R1 minus Rn only. So all rotation coefficients from this observation no longer depend on n entries. They depend on n minus 1 entries. They depend only on differences.
You always tell people for various structures.
Next step.
Your main structure comes, but for that structure comes from random structure. By adaptation. The projective structure underlying manifold is attained by reduction structure from
Okay. So it was, you see, first step and second step. Now I'm going to third step. I'm going to tell you about Frobenius manifolds. If you remember, I said you that here are coefficients which are constants, but this is not precisely correct. What means not precisely correct? Means that theoretically I can consider these functions as a functions of corresponding coordinate. C1 depends on R1, C2 depends on R2, but nevertheless, as I told you, by scaling in this nonlinear system, I can completely remove these dependencies. So I have two distinguished cases, or 0 or constants. I prefer to use constants on this language, but of course, actually, these are functions of corresponding independent variables, which I can again rescale back, normalize to unity every time. But now this is important why I'm speaking no longer about constants, but I'm speaking about functions. Because if I will speak about functions, this condition can be written in following form. You see, mu I of Ri, I have this set of functions. Mu I di beta ik plus mu k dk beta ki plus half mu I prime beta ik plus half mu k prime beta ki plus sum m not equal I not equal k mu m beta mi beta mk equals 0 for I not equal k. So mu I are arbitrary functions.
This,
Instead of C, oh yeah.
Instead of
functions in what?
If I add here these functions, so this equation will take form hi is mu I psi I plus mu I prime psi I plus sum m not equal I mu m beta mi psi m. Yeah, the same, yeah. So if I fix now mu I on unity, that I told you that this is possible to do every time if this is not a zero, then this term disappear because it's derivative. Here will be psi I, here will be this sum, so will be precisely this expression, yeah? Exactly. So if I keep this before normalization dependencies mu I of every Ri, I have more general form instead of this one.
Prime means derivative.
Prime means derivative.
And what do you say? Let us take some news such that this condition fulfilled or not. This is the definition of mu or
No. Again, I'm looking for transformation between one linear problem and another one as a first order. So this is general answer. General. No, general answer. If such a breach exists, this means yeah.
I mean, you have the same coefficients in terms of CII and CI. It's
Yeah. Mu I, mu prime.
okay, so it's a derivative.
Derivative.
On each side.
Yeah, derivative, yeah. Derivative.
yes, derivative of
Derivative of each side.
okay. So if you have such a transformation, then this condition should be fulfilled.
Yeah. So again, by rescaling, I can fix mu I to unity. I can fix every time. If such. Huh?
But we don't want.
No. I can do it and I do it. So I come here and I come here. However, statement is following that if I take some solution of this Darboux system, and consider this system of equations, it could be for given beta ik, for given coefficients beta ik, could be that mu I equal 1. This is not a sole solution, not a single solution. It could be one of some other solutions, could be two solutions, could be three solutions, could be four solutions. So here is a theorem that maximum of particular solutions is n plus 1. So n plus 2 solutions forbidden. It's impossible. It was proved. So this is maximum of possible solutions. And theoretically, we can separately write all cases when we have only two solutions, only three solutions, only four solutions, theoretically. But this is not yet done. If we speak about two particular solutions, this precisely, Hovik, that you asked me, this case of Frobenius manifold.
Can you repeat?
So if we take one particular solution, mu I equal 1, and mu I is Ri, So if we have two particular solutions, again, this is not general picture. I'm speaking about sub case. It's possible to find such huge space of particular solutions, Ri, one and second one. So I wrote this restriction, and this means that I write here Ri, Rk, here will be unity, here will be unity, Rm. So this third line, it will be definition of Frobenius manifold. This definition of Frobenius manifold.
So at the end, you begin from the equation. You have situated structure, Frobenius structure.
Yeah. Да. Так вот, so you see, if again I remember about this symmetric condition, and if I substitute everywhere here, you see beta ik, the same trick like here, I come to, under this symmetristic condition, some mu m dm beta ik equal minus half mu I prime beta ik plus mu k prime beta ki. So I call it again like some differential operator, like here, shift operator. If I take mu I is Ri, this is so-called scaling differential operator. R sum Rm d Rm, this expression, acting on beta ik, and here beta ki. So better to write here maybe in such a way, mu I prime plus mu k prime beta ik. Yeah, this better. So this condition here will be unity for this case, minus beta ik. So this is so-called homogeneity condition written by Dubrovin. So it will be plus R beta ik is minus beta ik. This is definition of Frobenius manifold. 1, 2, 3. Three conditions. 1, 2, 3. So all rotation coefficients should depend on differences. All rotation coefficients should have a homogeneity minus 1. That's all. Symmetric depends, every beta ik depends on differences, and degree homogeneity minus 1. That's all.
Can we tell that your result is
Dubrovin result.
Come to Frobenius structures.
Yes, this definition of Frobenius manifold. This is definition. Yeah.
This case.
Yeah.
One under R.
Yes.
This particular.
Yes, this particular case. Yes.
Then where that connection, the factor, given metric on vector one, and if you impose the scaling there, you eventually get the difference. If you want to impose it, you look at like arbitrary mu additions, you get like the properties of Frobenius structures, which less like properties, but gain from the same way. You can it looks like principle just bundles regardless, and then trying to construct less but more complete connections. For particular case, just a third order doing most of the absorption with symmetric. Therefore, in manifold things like a correlation with potential very We have many different.
So now I would like to tell you a little bit about spaces of solutions.
You get this famous F, that you should have this potential function, do you get the right one?
No. Of course, this famous function f is hidden in this construction. Actually, I'm not going to tell about this f. Yeah. Because for f, I need to just extend my talk maybe of half of an hour, and I would like to skip other details because I would like to concentrate on another more important in my talk statements. Just I would like to speak about space of solutions. So if we look again to this system of equations, this system of equations has this three-dimensional system, as I told you. Let's take any three indices, 1, 2, 3. So we have, for instance, d1, beta 2, 3, beta 2, 1, beta 1, 3, etc., etc. We have 6 equations, 6. If we take these conditions, this means instead of 6, we have 3. If we add this condition, this one, this means consider only particular set of solutions which depends on differences. If we add this condition, this means we consider space of solutions which is a homogeneous one. So, yeah. So we have 3D system. If we consider this restriction, still we have 3D system. If we, let's forget for a second, let's forget. If we speak about this condition, we again speak about 3D system. So we have one 3D system, we have second 3D system. One 3D system is here, one 3D system is here. On intersection of these two 3D system, we come to 2D system. 2D system, this object which was interested, for instance, for Dubrovin, this I removed, yeah, I removed everywhere. So я сейчас сотру. So I just would like to say that if we add new and new conditions, we reduce space of solutions. We have 3D system, we preserved 3D system, but if we take combination of these 3D system, we come only to 2D system. If we consider this scaling condition, we come to 1D system. 1D system, what means 1D system? This is Penlevier. Frobenius manifolds and Penlevier, so people call isomonodromic deformations. Not finite gap solutions, not algebra geometrical solutions, but a little bit wider class of solutions which people call isomonodromic deformation. So where are isomonodromic deformation? Here. Isomonodromic deformation are here, 1D system.
Three-dimensional drawing Frobenius manifolds, the same as
Penlevier 6. Penlevier 6.
6.
And moreover, Penlevier 6, to the best of my knowledge, contains 4 arbitrary constants. So when we are speaking about this particular case, maybe I'm wrong. This means it depends only on one arbitrary constant. 3 other are fixed, but I'm not sure. Okay, so this is such a story. And now I'm going to finish. So what was description again of Dubrovin paradigm? Because now all that I told you, I am on side of this approach, Dubrovin paradigm. What is it? I have symmetric rotation coefficients which satisfy this shift condition and this homogeneity condition. Here is a following point. It's important to emphasize. For instance, I said you, let's fix mu to unity, mu to Ri. It was proved by Dubrovin, this elementary computation, but a little bit routine lengthy computation, that if mu, for instance, you say, let's take mu bar and mu twiddle, two particular solutions, let's take. every time you can fix to unity and Ri. So if you say, let's consider instead of Ri square, why not? You can, but by rescaling, you can come back to linear dependence. It was proved. Maybe better to say, do not refer to Dubrovin. Maybe it was known by Darboux. Yeah, this elementary computation. So if you take two particular solutions, definitely you can rescale beta ik and corresponding independent variables Ri in such a way that you can choose mu I as unity and other set of mu I as a corresponding values Ri. That's all. So do not invent something like Ri square, Ri cube, etc. This is not necessary. By proper scaling, you will come back only to these two conditions. So, for instance, you can say, what could be if you add third condition? 1, 2, let's add third condition. Of course, you can. And it will be a more narrow space of solutions than 1D. This means like some marked points. You will take some particular corresponding solutions. Of course, it's possible, but also this case is not yet investigated. Yeah. But I just would like to say that this is not so complicated problem as was presented here. Yeah. Anyway, I'm not going to stop here because I just described Dubrovin paradigm. Now I'm going.
Макс, простите, а мы когда вот эти три условия пишем,
Да.
мы про саму систему Дарбу забываем.
Нет, помним,
помним,
да,
да.
помним. Вот она у нас есть. This our system plus this condition and this condition. Yeah. Да, всегда, every time. Yeah, every time. So, okay, now I will erase something here. I will erase. And I would like now to go back to Bogdanov-Ferapontov approach. For instance, you remember this big expression, yeah? We have transformation between psi and hk here. We have two linear systems where we have this second order differential operator. We have restriction for rotation coefficients beta ik, where functions ui can be reconstructed from this extra set of conditions, this set of nonlinear equations. So what I would like just to tell you that instead of this condition, or could be functions of corresponding Ri. Yeah, in this formula they constant.
Necessarily constant.
I don't like to say exactly.
They are constant, and I thought they can be one. Where is the
Yes.
Where is the extra generality?
I just follow them. Of course, you can fix to unity. Of course, you can fix. Yeah, of course.
For free extra relations between betas. Your scanner scaled up, but you realize some manifold of initial data where you don't see
So we had these three statements: symmetric rotation coefficients, they depend on shifts, and they are homogeneous. But instead of these three conditions, you can take any conditions from Bogdanov-Ferapontov approach. That I just would like to tell you. For instance, I say, let us condition when we are looking for second order differential operator, and let's, for instance, of seventh order. Why not?
Do you say to say as the Bogdanov-Ferapontov approach?
Yeah.
It is projected geometry.
Yes.
It's projected.
Yes. Precisely. So my claim is that instead of conditions which were naturally considered by Dubrovin because they are simplest and very understandable. So when you look on equations, you immediately interested to consider some symmetric cases for rotation coefficient. They are interested to consider local Hamiltonian structure of Dubrovin-Novikov type. Also, this is obvious. If you take two combinations, I mean like this one and this one, this means you are looking for solved by Hamiltonian structure. All of them are very natural from that point of view. So all that Dubrovin did, it's natural. So I'm going now to tell about extension of this construction due to Bogdanov-Ferapontov approach. Extension means that instead of operators of zeros and first order, I can take any differential operators of high order, fifth and seventh.
What is the sense?
Ian, I suggest you read paper because I am interested just in algebraic manipulations in my talk, not in geometry. I just would like to say that you can take any higher order differential transformations between one linear problem and a joint linear problem you take and compute corresponding restrictions. For instance, you can keep this one, you can keep symmetricity, but instead of this one and this one, take some other restrictions, which for instance, simplest one you see here, and completely repeat similar computations. You will come to similar objects like Frobenius manifolds. Similar means not the same. I mean, you will come to objects which come from a similar set of restrictions.
Frobenius structure will actually open set. For instance, for the basic case of first order correspondence, you have bijection between Frobenius structure, projective structure, and Darboux systems. This first order symmetry between two last representations. Full picture, but if you go to higher orders, you get some more exotic stuff. Which corresponds to like projective structure is the extension. It has like principal bundle is absolute extension of GLN by vector space with in X. But you can take kernel jets as the kernel of this extension and look for solutions for flat but not necessarily free connections. Well, this space for bundle. I mean, for columns, it's like calls Frobenius structure on symmetric columns. It's 1.5 months old, but this ideas for like ideas are kind of old, but they don't it's written down. It's finally written down. But not any comment. I can no right. Not any from Japan. As far as I remember, yes.
Okay, so what I would like to say, you can call keep symmetricity, you can keep flatness condition, and for instance, you can forget about third. That was from Dubrovin approach. Third one, where mu I fixed to Ri. You can say, let's just consider this extra restriction. Third one. It will be not Frobenius manifolds that I would like to say. This one and this one. It will be not a Frobenius manifold. Again, let me emphasize, this is not a Frobenius. This is different object. But different object also interesting. Why interesting? Because this again direction how to solve this original Dubrovin system of Darboux system of equations. And what is the point? Again, this is 3D system. You add this restriction, you still in 3D. You add this restriction, you are already in 2D system, 2D. But if you add this extra restriction, I'm speaking about second order, this means you again come 1D. 1D. And the question, what means 1D? In Dubrovin construction, it was Frobenius manifold, it was isomonodromy deformation, equations of Penn-Levé type. The question is, what could be under this restriction? Interesting.
And you didn't do it.
No.
And you don't.
I am speaking just about open space of solution. Yeah. So actually, I'm finished. Thank you.
Maxim has huge collection of open problems.
Yeah.
in general.
Huge. Actually, this picture looks simple. Take just like Lego game. Take just parts.
you state that your result is that you consider Frobenius structure of the manifold.
No. My result is just collection of results made by Dubrovin plus results obtained by Bogdanov Ferapontov. That's all. Collection for your attention.
May I ask a question?
Yes, please.
Max, so if you take, say, Yegorov symmetry condition plus flatness plus this second order condition,
Yes.
right? What do you get? What sort of ODE will it be? Will it be Penlevier? Have you done calculations, even in the simplest case?
Zhenya, it was just question of in Marshall 1 minute ago.
Sorry, I couldn't hear.
I said that in result you should come to another class of solutions which definitely not Penlevier type,
Not Penlevier.
not Penlevier.
Have you done a calculation even in the simplest case? In the simplest case, say 3 component.
Yeah. Zhenya, I don't know.
You haven't.
I not. Me not.
Okay.
So we should not expect that we will come to known results. It will be new results, definitely, because another systems of equations, another.
But
This-
Max, there is a general philosophy that all reductions of integrable systems must be Penlevier type. Why are you saying it's not Penlevier? It's strange, really.
Yeah.
Controversy.
Not controversy.
So this is to make.
No. This just
Just think the answer to Jenny is that you're offering him some controversy to give some spice to his interest.
I just would like to say that I prefer do not refer on all known results. And okay, and what? All known results were known as Penlevier class solutions, and why we should refer on these solutions. These results with Penlevier were extracted from investigation of 2D systems like KDE, but it's 3D, another class of solutions.
This thing here after reduction is 1D.
Yeah, 1D.
So it's
1D, yeah. We have first equation, second equation, and now we have third one. It will be another class of 1D equations. Another, why we should need to expect again Penlevier? Why? No reason. No reason to expect. Вот это все. Алик, а там много слушателей-то, кроме Жени?
Если повысить порядок, еще там совсем.
15 всего. Ну, вы всем говорили, что получается 16.
In another language. If you are interested in F capital,
Right.
prepotential, from these two conditions, this means that such function exists. Yeah, so when we speaking about Frobenius manifolds, this means that for F capital, we take some particular solutions, but instead of that particular solution which come from isomorphic deformations, we can take corresponding set of solutions. That I would like to say.
I think I write HI is equal to 1 divided by psi.
Okay. No.
No, Макс, верно, что значит порядок этих самых условий, он совпадает с порядком преобразования.
Да, конечно.
Что мы можем там наверное, уравнение 125.
Да, совершенно верно. Я и говорю, никакого шанса. Да.
Can you recall the programming structure?
One restriction, second restriction, this one and this one. Yeah.
Max, once again, why it's impossible to write HI is equal to 1 divided by psi?
You have one linear system and you have second linear system. You're looking for transformation which is determined by differential operator acting on psi.
I would like to search for the
Yeah. Okay. You're very welcome.
Nothing, no activity in this direction.
No activity. Yeah. Strange, yeah? What?
The answer, as far as I see, the answer will be beta ik is equal to minus beta ki.
Good.
Is this restriction contradictory to anything?
No. Your idea is wrong. That's all.
Why it's wrong?
No solution.
No skew-symmetric solution.
HI is 1 over psi I. Это вы называете косимметричным?
Не, тогда матрица.
Он приходит к косисимметричности бета.
У вас там сопряженная матрица, а тут она будет косо-сопряженная.
When you take this CI, you write here CI beta IK is CK beta KI. Of course, you can take CI CK in such a way that here will be -1. Yeah. This is just inconsistent.
This whom?
One set of second one. Yeah. Oh, Олег, okay, substitute, please.
Well, I said the answer is beta ik minus beta ki.
Не понимаю. Я тоже не понимаю. Ну, хорошо. Публикуй статью, все. Нет. Ну, это чушь просто и все.
Multiply both sides by psi I.
Олег, ну не хочу я обсуждать дурацкие вопросы, а? Ну сделай, ну чего ты? Ну все, публикуй. Все, будет опубликовано, гарантия полная. So again, concept of Bogdanov-Feraponta was following. We have one linear system of we have a joint linear system. We are looking for differential operator of arbitrary order, pure differential operator, connecting one solution and another one. That's all. Another option, Oleg, are open. Please follow. Infinitely many other options.
Ну, мы к обыкновенному уравнению только в трехмерном случае спускаемся.
Нет, всегда.
А почему всегда? Потом добавляется условие.
Ну вот, я же вам говорил. Вот это условие и вместо этого другое условие, там всегда так будет. Потому что там расщепление всегда идет по... Вот видите индексы 1, 1, 2, 2. Всегда расщепление по двум индексам. Олег, а там иностранцы-то есть слушатели? Может, уже не надо говорить по-английски?
Есть пока не один китаец, китаец.
Да? Я уже забыл, как я его одел.
So thanks a lot. Questions, remarks? Женя, do you have something to add? Отключился? Well, thanks a lot. So the next meeting will be in Zoom, and the meeting in 2 weeks will be again live. Max, thanks a lot. It was very interesting.